So now you can open here these parameters. So if you want to change these parameters, just click this parameters folder here and take these cut parameters. And here you can select compensation direction left and right. So it looks like many of you this is now wrong, because if we use line for toolpath generation, it can't know that which one is material side. So here you can change this compensation direction left to right or right to left, and OK. And then you can see here is this this red mark. So it means that you have to generate these toolpaths. So that's why select this one, regenerate all the operation. So it's calculate to you new toolpath. But as you can see in my case now, that side is wrong. So it's make it like this. Okay. So now when I want to fix this problem, again, I take parameters and I take cut parameters and I change this compensation direction right to left. Yes, here you can give retract plane, feed plane, top of stock and depth. And now you can see that that tool length is shorter than this one, so you can set this depth, for instance, 30 millimeter. It's not so deep. And again, regenerate, and now we can see what will happen. Okay. And next we can change this value. Now you can see that it's make this toolpath one time. So what if I want to make it smaller slices? So how can I do it? So I go back to parameter and I take depth cuts. I select depth cuts and max roughing step I give 3 millimeter, for instance, and I don't make finish cuts now because it is not pocket. So yes, 3 millimeter and OK, and generate. Now you can see what will happen. It's take 3 millimeter minus 3 minus 6 minus 9 and so on. Well, maybe this is too small. If I want to make bigger slice, I can go back to parameters and give, for instance, 5 millimeter. So now it's make 5 millimeter per one time and 30 millimeter, so it's mean 6 round. Minus 5, minus 10, and so on. Okay. And actually here you can see this compensation type, and here you can see these choices, computer, control, where and off. And actually what this means, so it's actually mean this one, how you can use cutter radius compensation. Don't use, of course, it's this one, off. And computer, it means that it's calculate that radius compensation from geometry. But if you want to use full tool radius compensation, it means control. If you use this control, actually it means that it's calculate that tool paths. It make tool paths here, but after that it want to move that tool left or right side for full radius. But typically it's not very used because it's much more typical that we use cutter radius compensation only with tool wearing. So it means that it's if you select wear, it means that it's move that tool paths left or right side. It's calculated already because it's no tool diameter. But then you can just fix that tool paths only 0.01, 0.02 millimeter left or right. So actually what you can use for these choices, typically use this computer. This is you can use this one, or you can use where, or you can use off. But this computer is default value for this one. But you can use computer or where, or you can put it off. Okay. Well, what we do next, we can make that pocket milling. So here you can see pocket, and it's 20 millimeter deep. So you can select here pocket and this chain icon and select this line, only one line, and program will find that it's loop, it's chain. Okay. Tool, and now this 20 millimeter tool is tool length. So we can select little bit smaller tool. So we can go to library, and here we can find flat end mill, and diameter is 10 millimeter. Flat end mill 10 millimeter. Here, select this one. And now we can give tool number, and it's 8. So tool number is 8, so length offset is 8, and diameter offset is also 8. Feed rate is 800, so feed per edge is 0.1, and spindle speed, we want that cutting speed is 100, so it's about 3000, little bit more, 3200 maybe. Okay. So you will see those parameters here. Okay. Cutting parameters. Here you can give information machine direction, crimp or conventional. So what this one means? It means if you look here, this one is crimp, and this is conventional milling. So this direction cutter rotation is different than material feed. And if we make crimp milling, then material feed and cutter rotation is same. So we can give information crimp or conventional. And yes, here you can find roughing, and here you can find different method what you can do. You can use zigzag or parallel spiral or high speed, one way, and so on. And you can select different method. In this case we can take this zigzag for instance. Linking parameters, again 20, 10, 0, and this depth is -20. And coolant on. Okay. And now you can see what is the problem. If you make this simulation, first it's have to make drilling when that tool go inside that material. So of course we have to use tool which can drill, because it's possible that all end mills are not suitable for drilling.